Hello and welcome to today's reasoning on logical reasoning. This is the second part in two videos that covers the topics in Standard 1.1 in geometry and that study island topic, logical reasoning. So today's lesson is going to deal with the questions that talks about logical reasoning, the Venn diagrams, inductive versus deductive reasoning, and then also conclusion versus hypothesis. So some of them are pretty easy questions. You just got to know the vocabulary. So if these are vocabulary words that you're not super familiar with, then you might consider making some flashcards and taking really good notes so that you can have something to study afterwards, because once you get the vocabulary down, these are pretty much gimme questions on the EOI, which we could all use some gimme questions. Now, out of these two parts, so out of this whole study island topic of logical reasoning, there's about 4 questions you will see on the EOI with these topics. So I'm excited that you're here, and let's go ahead and start our lesson.
All right, so this first one is a Venn diagram, and let's go ahead and read it. A total of 100 homes participated in the Yard of the Month contest. Of those participants, 35 planted roses, 36 planted tulips, and 54 planted gardenias. Of these homes, 9 planted roses and tulips, 12 planted roses and gardenias, 9 planted tulips and gardenias, and 3 planted all types of flowers. How many participants planted only roses? All right, so what you have to know is this 35 planted roses up here includes all parts of that circle. So it includes just roses, roses and tulips, roses and gardenias, and all 3. So that's the trickiest part about reading these. So I would make sure that when you're doing a Venn diagram problem that you copy this down, so that you can write the numbers in it so that you can see it instead of trying to do it all in your head. It just makes the most sense to go ahead and copy this all the way down. So the first thing, and then I'm going to go ahead and fill the numbers in. So the first thing I'm going to do is I'm going to write this 100 down in the corner because that is the total number. And then it said 35 planted roses. So underneath roses, I'm going to write 35. It says 36 planted tulips, so under tulips I'm going to write 36, and then I'm going to write 54 by gardenias. Okay, so of those 9, or it says 9 planted roses and tulips. So just so you know, that includes the all 3 and just roses and tulips. So that 9 is this piece right here. So I'm going to go ahead and write 9 here, but knowing I'm probably going to cross that out once I figure out how many are just roses and tulips. And then I have 12 are roses and gardenias. And then I have 9 are tulips and gardenias. And then I have 3 that did all 3. All right, so I'm going to go ahead and figure out how many are only roses. So if I'm going to do that, I need to find out how many are at just roses and tulips. How many are just roses and gardenia. So I need to start working backwards. Well, if I know 3 are all 3 and 9 is both these pieces, that means this piece here is going to be 6. Because 9 is that representative of both pieces, so I know 3 plus 6 is 9. Okay, and then I'm going to do the same with the 12. I know 3 of those are all 3, so that means I have 9 of just gardenias and roses. Okay, then I have my roses are a total of 35. So that 35 comes from all 4 pieces here. So if I want to find out how many are just roses, are only roses, I'm going to have to subtract out these other 3 pieces. So I'm going to have to take 35 minus 6, which is 29, minus 3, which is 26, minus 9, which is 17. And so that leaves 17 for only roses. So my answer is D. Here's another example with a Venn diagram. At Adams High School, 350 students have a laptop computer at home, 404 students have a desktop computer at home, and 62 have neither a laptop nor a desktop computer at home. If there are 606 students at the Adams High School, how many of them both have a laptop and a desktop computer at home? So I'm going to go ahead and I'm going to start by filling in the number. So if I wasn't able to write on this picture, I would definitely copy it down in my notes. So the first number they give us is 350 laptop computers at home. So I'm going to write 350 underneath laptop because remember that includes only laptops and both laptop and desktop. So then I have 404, which is the desktop at home, and I'm going to write that underneath because that includes only desktops and both desktop and laptop. So I have 62 have neither, so I'm going to just write that over here on the side so I don't forget about that number. And then there's a total of 666 students. So I'm going to write that above at the top here. So it wants to know how many of them have both a laptop and a desktop at home. So my first step is going to be to find out how many of them have either a desktop or a laptop. So I have a total of 666, and I'm going to subtract off the neither. So that leaves me with 604 that either have just a laptop, just a desktop, or both. My next step is going to be to add the 350 plus the 404, so the two numbers they gave us for the laptop and desktop. And when I do that, I get 754. Okay, and so that gives me the laptops, the desktops, and then it gives me the both laptops and desktops twice because I'm counting this whole circle and this whole circle. So this counts an overlap. So to get rid of that overlap, I'm going to subtract 754 minus 604. And when I do that, it's going to be 150. So that means there's 150 that have both a laptop and both a desktop at home. So my answer is going to be C. All right, the next section of questions we're going to look at talk about inductive and deductive reasoning. So let's go over those definitions. Inductive reasoning is used to draw a general conclusion from specific instances. It is often based on examples or observations. The conclusion of inductive reason is not mathematically certain. It's often a guess. So this is more like going with your gut, making an assumption. Whereas deductive reasoning uses the application of a general rule to draw a specific conclusion. Deductive reasoning is based on mathematical certainties. So if you deductively reason something, you know for certain that's going to happen. You've proven it's going to happen without a doubt. This first example says, each person Kimberly has met at North High School so far has been very friendly. Kimberly now believes that everyone at North High School must be friendly. This is an example of, and we haven't got over conclusion and hypothesis yet, but it's going to be inductive or deductive reasoning. So since it's more going with your gut and making an assumption, this is going to be inductive reasoning, letter B. This example reads, every person Aaron has had a pet has hated cats. Aaron now believes that all dogs hate cats. This is an example of, since this is more of a guess, it can't be mathematically proven, it's an assumption, a guess, it's going to be inductive reasoning, letter D. This example says the members of the Moore family are Tommy, Kathy, and Amy. Amy has blonde hair, Kathy has blonde hair, and Tommy has blonde hair. Therefore, all the members of the Moore family have blonde hair. This is an example of, okay, you know that the Moore family has 3 people, and you know those 3 people have blonde hair. So you know without a doubt they all have blonde hair. So this is deductive reasoning. Which of the following is an example of deductive reasoning? A. Jane flipped a coin 10 times. It landed on tails every time. Jane concludes that the next coin flip will land on tails. Well, deductive reasoning is something you can prove without a doubt, with 100% certainty. And since every time you flip a coin, you have 50% chance head or tails, she can't prove it's going to be tails with 100% certainty. So this is going to be not going to be A. The next one says, Sancho thinks that in order to be on the swim team, a student would have to know how to swim. Since Mia is on the swim team, Sancho concludes that Mia knows how to swim. Well, you know that being on the swim team means you can swim. And you know Mia's on the swim team, so you can conclude without a doubt that she can swim. So the answer here is going to be B. But it's always a good idea to check all of your answers and see if you can eliminate the other 2 also. Letter C says, Hillary arrived at work late on Monday, Tuesday, Wednesday, and Thursday. Her boss concludes that Hillary will be late to work on Friday too. Well, maybe something will go different on Friday. Maybe there won't be as much traffic. Or maybe she sets another alarm because she learned her lesson. So you can't prove that with mathematical certainty. It's more he's just going with his gut. So it's not C. D says Becca has worked out at the gym for the past 6 days. Matt concludes that Becca will work at the gym today as well. Well, I mean, it makes sense. You're kind of going with your gut. You're kind of assuming that, but you can't prove that without certainty. She might get the stomach bug, or she might sleep in, or she might have somewhere else to go that day. So it can't be D. So it's definitely B. The next thing we're going to learn about is the parts of a conditional statement. So the conditional statement is an if-then sentence. So if you go to bed early, then you will wake up rested. That's a conditional statement. The hypothesis is the phrase immediately following the word if in the conditional statement, and the conclusion is the phrase immediately following the word then in a conditional statement. So if I look at this example, everything after the word if but before then is the hypothesis. So I eat a gallon of ice cream is my hypothesis. And then everything after the word then is my conclusion. I'll be sick is my conclusion. So in this example, the conditional statement is, if it is Wednesday, then Amy works from home. Which of the following is the conclusion in the statement above? So everything after the word then is my conclusion. So Amy works from home. So my answer is going to be D. This example says if the sales quota is exceeded, then the salespeople will get a bonus. Which of the following is the conclusion in the statement above? So conclusion means I'm looking for all the words after the word then, which is the salespeople will get a bonus. So that means my answer here is D. The last 2 questions we're going to look at here are just general logical reasoning questions. So these don't fall into any other categories. You just have to think through what order things are in. This one says Courtney is enrolled in 4 courses at a local college that all meet on the same day. If she goes to psychology before she goes to statistics, but after she goes to economics, and if literature is the next to last day class of the day, which class does Courtney go to first? So I'm going to make a list using the information I was given here. First, I was told psychology before statistics. So that means that psychology is before statistics. Okay, so it's earlier in the day. But after she goes to economics. So psychology is after economics. So that means I'm going to write economics here. Then the last piece of information I'm going to get is if literature is the next to last day class of the day. So notice I left room in case I needed to write something else in. So lit goes here. So which class does Courtney go to first? It's going to be economics, D. This example says, Glenn, Jim, and Mark are the 3 finalists in an academic competition. The questions are asked in rounds where each participant gets 1 question and the same order is followed each round. If Glenn answers his questions right after Mark and Jim answers the first question of each round, who is answered the 24th question of the competition? So let's go ahead and write the order they go in. So Jim answers the first question of each round, and Glenn answers his questions right after Mark. So Glenn is after Mark. That means this is the order they must go in. So first, second, third. So the 24th question of the competition, well, if I multiply these each by 8 because 24 would mean there's 3 of them, so 3 divided by 24 is 8. That means 8 times 3, Glenn is going to go 24 for the 24th time. So my answer here is C. Thank you for joining us today, and I hope you learned something new.